In this video, we will discuss moment of inertia of a disk about a tangent perpendicular to the plane of rotation. And we will use here the perpendicular axis theorem and parallel axis theorem. So, how will you find out? Now, you know that for a disk, if this is the axis that is about z axis, let's say, so Iz, moment of inertia about the z axis, that means the axis which is passing through the center and perpendicular to the plane of the rotation, then we know that Iz equal to half mr square. Its derivation is already there. I'll share the link also. Now what we'll do, we are interested to find out the uh, moment of inertia about an axis which is perpendicular to the tangent plane. Perpendicular, which is a tangent, the moment of inertia about the tangent and perpendicular to the plane of rotation. That means this disk will rotate like this about this axis. Let's say we'll find the moment of inertia I dash here about this axis. This is a Iz, moment of inertia about an axis perpendicular to the plane, and it is known to us. Now what theorem we'll use? We'll use parallel axis theorem. You can see that this axis and this axis are parallel to each other. So we can easily use the parallel axis theorem. So parallel axis theorem says, what is the parallel axis theorem? Parallel axis theorem. From parallel axis theorem, what we can write? That your I dash moment of inertia equal to Iz plus m, the distance, mass of this one, m d square. Here d is the radius, distance between the two axes. So m d square or mr square here. So Iz is what? Already known to us, half mr square. So Iz is already half mr square, and this is md square is also mr square. So you can write half mr square common. So you can say half plus 1 mr square common. So it's 3 by 2 mr square. So this is the rotation. Suppose this is a disk, so it is rotating about like this, about this tangent axis which is tangent to the disk, right? So we can use the parallel axis theorem and easily we can find out the moment of inertia about an axis that is tangent to the disk and perpendicular to the plane of rotation, right? Also we can find out parallel to the plane of rotation. That means the tangent which is like this. And so here what will be the moment of inertia? So you can use parallel axis theorem, but take a axis about the diameter. So in the last video we have found out the axis which is moment of inertia about the diameter. We have found out that is y 1 by 4 mr square, and this one will be md square or mr square. So about an axis, this is the tangent axis which is parallel to the diameter. Let's say I double dash, or so you can write this one is 1 by 4 mr square plus mr square. So this one will be 1 by 4 plus 1. So this is 5 by 4 mr square. This one will be, so about axis, this one will be your 5 by, you can write here, it's 5 by 4 mr square. So your moment of inertia about a tangent parallel to the diameter, that is equal to 5 by 4 mr square. Right. So in the next video we'll discuss some other topics. Thank you for watching.